Hi guys, this is experimental chemistry and we are looking at the apparatus commonly found in a chemistry lab and their uses. Pipette. A pipette is a piece of apparatus that is used for measuring accurate volumes, but those which are fixed, meaning they cannot be variable. So we have pipettes of different volumes available. The ones shown here are 1 centimeter cube, 5 centimeter cube, 25 centimeter cube, and other pipettes that can be found in a lab could be 50 cm cube, 100 cm cube, and even 0.1 cm cube. So the one that is commonly used in a high school chemistry lab is the one having a 25 cm cube volume. So if you can see, the volume stated is 25 ml. So 1 ml, ml stands for milliliter, is equal to 1 centimeter cube. So 25 ml is equal to 25 cm cube. So a pipette is used by using a pipette filler to take up solution from the tap at the starting up right up till the mark that is shown here. If you can see, this is the mark, and the lower meniscus for colorless and clear liquids and the upper meniscus for colored liquids would be set at this mark, and the liquid would be pulled up using a pipette filler and also removed using a pipette filler from the burette. So of a pipette, not burette, from the pipette. So the pipette here will be used to measure 25 cm cube of the solution. Now we have on the pipette on the right a value written as plus minus 0.06. This is the error of a pipette, and error of a 25 cm cube pipette is fixed, and so is the volume. So when we measure 25 cm cube of a solution using a pipette, we can calculate its percentage error by dividing 0.06, which is its error, by the volume taken 25 and multiplying this ratio by 100. This gives us an error percent of 0.24%, which is lesser than the error using a single volume reading of a burette, because when we measure 25 cm cube using a burette, the error is 0.1 upon 25 into 100, giving us an error of 0.4%. Using a pipette, we have an error of 0.24%. So if we measure the same volumes of solution using a burette and a pipette, the pipette becomes the more accurate apparatus of the two. However, pipettes with fixed volumes can only be used. So the use of pipettes would be limited to experiments where such fixed volumes are needed. Other than these, if we have to use variable volumes, we would need to use burette for measuring accurate variable volumes. So pipettes are used during titration to take solutions into the conical flask and to titrate them against the solution taken in a burette. So the volume of the solution in the burette will be variable based on how many moles of the other solution is present in the conical flask, and the volume in the conical flask would be fixed because that solution was taken up using a pipette. This is a pipette filler that is placed at the mouth of the pipette and is used to draw solutions into the pipette. So we have labels on the pipette filler as A, which is the air valve. This needs to be pressed, and then the bulb needs to be squeezed to let the air out. So when we press the A at the top of the pipette filler and squeeze the bulb, it lets the air out. This creates the this creates the pressure that will pull up the liquid from the container up into the pipette itself. So the next label here is the suction valve. The suction valve is the one we press to pull up the liquid into the pipette, and obviously we stop at the mark where we need to fill the liquid up to. Then, once the liquid has been drawn into the pipette, we take the pipette out from the container from which we were drawing solution, and we place it in the conical flask, and then we press the E button on the pipette filler, which is for emptying the empty valve. The empty valve lets out the solution from the pipette. And in case during pulling up of the solution into the pipette, if the solution stops at a particular level and we need to draw more of it, we would hold the pipette with one hand, and with the other hand we would press the air valve and squeeze the bulb again so that it can create pressure to draw more liquid. And then when we press the suction valve, it would draw up more solution so that we can have the solution up to the mark where it is required. And again, by when emptying, we press the empty valve to release the solution from the pipette into the conical flask, or whichever piece of apparatus we need to collect that solution in. We keep pressing E until all the solution goes out. If there is solution left at the tip of the pipette, all we do is just twist the pipette at the bottom of the container in which we are letting the solution out in. We do not shake, jerk, or blow the solution out of the pipette. That is another thing we need to remember when a pipette is used.